Okay, so now that we've done a little bit of work about on functions and writing different functions, including quadratic functions in different formats using Algeblocks and manipulating the algebraic form of it and making sense of that geometrically, we now need to look at a couple of other representations of functions. So specifically, we're going to look at the table of values and a graph. And we're going to analyze different families of, well, actually the one family of functions, which is x squared, and so the squaring function, and how it's impacted by different transformations. So the idea is that, let's say we're going to take a look and analyze the x squared function. So the x squared function with and see how it's impacted by adding a number, perhaps adding a 3 or adding a 5, or say adding h, just a general number. So the way we're going to start is we're going to create a table of values for these functions. Now I've prepared a table of values before, so I'm going to go down and copy that from what I've already prepared, so that we don't have to spend the time here recreating it. Okay, so let's fill this in. We have the table of values here, and we're looking at if we're looking at the x squared function, just the base function, we see that it starts at 0, and then it has 1, 4, 9, 16, 1, 4, 9, 16 going in both directions. We got that from, say, squaring -2 is 4, and squaring 2 is also 4. So we have this kind of a symmetry. Now, you notice that when we look at the second function, g of x, we're squaring, but then we're adding 3. So we're squaring whatever the input is and then adding 3. So you notice that what happens with each of the values here is that instead of 0, we have a 3. Instead of 1, we have a 4. Instead of 4, we have a 7. Do you notice that every value is 3 higher, but we still have the same kind of structure, that we're at 3 in the middle, and then we have a symmetry of sorts with 4, 7, 12, and 19. And in fact, the same with the 5. We start at the 5, and then we have 6, 9, 14, 21, 6, 9, 14, 21. And what happens with, I'm going to erase some of this, what happens with those values is we go from 0 to 5, from 1 to 6, from 4 to 9. Notice that they are all 5 points higher than what the original x squared was. So what in the table of values, what's happening is the pattern is actually staying the same. It's got some kind of a center at the 0 mark, and then it has symmetry to the left and the right. But what happens is the points in the second function are 3 greater than the points in the first, and then 5 greater for the third function. So what I'd like you to do is take a minute, pause this video, and just write down your observations, a generalization of your observations of how the values compare. Now with t of x, we're going to start with 0 plus h, right? And then we're going to have the same pattern, but we're going to be adding h. So it'd be 1 plus h, and 4 plus h, and 9 plus h, and 16 plus h, and on the bottom as well, going into positives. Okay, so you notice, I hope, that these are still the values for our x squared. And then we have the plus h. Okay, so go ahead and pause this video and complete your generalizations for what happens to the values for the functions. When we look at graphs, we can use technology to graph it. Go ahead and use your calculator or go online. It's up to you. I've done this already, and I have created a graph for the three functions that we're talking about. And here they are. So if you take a look, again, we're seeing that pattern in the x squared. So you see it's going to be lowest at 0, 0, and it's going to go symmetrical to the left and the right. So for example, at 1 it'll be 1, at 2 it'll be 4, at 3 it'll be up to 9. And the same thing at -1, -2, etc. So what happens to the orange one, to the G, and in this case they're renumbered, F1, F2, F3, but that's okay, it's just the technology I wasn't able to rename them. Oops. So the second function is going to have exactly the same shape. It's going to be lowest in the middle, and then it's going to go higher, and it's going to be symmetrical. But notice what happens here. It was 3 higher. And then finally the last function that we're going to graph is the +5. Notice what happens here, but the shape of it doesn't change. So what I'd like you to write down some observations that you notice about these three functions. And what do you think is going to happen to t of x, where we are adding h to the x squared? And finally, let's talk about f of x minus 2. So f of x is our squaring function. So v of x is the squaring function minus 2. So if adding 3 and adding 5 to the value of the function shifted them up 3 or 5, respectively, what do you think is going to happen when you subtract 2? Test it out. Use your technology. See if you're right. Get a table of values. So to model what happens and check if you are correct. Now, so what we did before was we took the x squared, and let's say for one of the functions we said x squared, and let's add, well, 3. Let's add 3, right? So square the number first and then add 3. Okay, that's fine, and that shifts it up or down. Now how about what would happen if we, before squaring the value, we actually added 3, for example? Right? So that's a different operation. We take our x, we take our input, and then we add or subtract from it, add to it or subtract from it first, and then we square. So let's do a little bit of exploring of what's actually going to happen with this case. I did exactly the same as before. I pre-filled out our table. So we will use it here. Okay, so what we're seeing, do you remember from before that we have a 0, 0, this is our x squared, and then we had a symmetrical pattern going on either side, so 1, 4, 9, 16, the perfect squares. What do you notice here? So let's say we have adding 2 first. Well, do you see the 0, 0? And do you see the same pattern happening on both sides? So what actually happened is somehow it shifted. It shifted from 0 to -2. So at -2, the whole function is 0, not at 0. And does that make sense? Well, when the value of x is -2, the value in the parentheses is 0. So we are squaring 0. But that happens at -2. So let's see what happens at +3. We have a 0 here, and then again, there's that pattern. So it would, in this case, the 0, 0 value shifted to -3. And look at that. Again, when x is -3, the value inside the parentheses is 0. So we're still effectively looking at squaring 0. Now with h, I'd like you to fill this one in for generalization, and also take a look at how you could explain that using words. You can pause the video while you do this. Now let's take a look at graphs. Just like before, I've prepared the graph for us to look at, and you can create it using either the graphing calculator or any kind of technology. You can even do it online. So what we have here is, here's our base function, basic x squared. Okay, it starts at 0, 0, and we have the same pattern that we're used to. Okay, same pattern that we're used to. Now, notice that the x plus 2 function, x plus 2 squared, has the 0, 0 at minus 2, so that must be this one. But the pattern to the left and the right of that is still the same. Look, it actually shifted. The lowest point, the vertex, to the left too. And then finally the plus 3, well, that shifted it to minus 3. So these points, this point and this point and this point, is when we are squaring 0. But that happens at different locations on the x-axis. Right? It happens at 0 here, it happens at -2 here, and it happens at -3 here. So I'm going to let you fill in this and this, and then see if you can figure out what happens with f of x. So what happens, what this is saying is that we're going to subtract 2 first, and then square it. So what do you think this is going to look like in the table and on the graph? So fill that in before moving on. Now let's put it all together. If you look at this table, we have our x squared base, and here in the g of x, we're going to add 3 and subtract 1. So we're going to add 3 first before we square it, and then we're going to subtract 1. And the same thing for s of x and t of x. So create the table of values. And I've done that already. So I'm going to import them here. Okay. So we're going to create the table of values. And we're going to look at what's happening, try to observe what's happening with the values here. So let's see. We're used to our function, our regular function. Okay. And do you remember what adding 3 to before squaring meant? Right? Do you remember what it meant? It meant that this whole thing equals 0. What you're squaring is 0 when x is minus 3. And then you need to, once you do that, you need to subtract 1. So we're going to move down 1. So let's look at the pattern here. Do you see that there's something happening at this point where it's the lowest? And then there's a certain symmetry. Right? So it's the lowest at minus 3. And it goes as low as minus 1. That's really interesting. Well, let's look for the pattern in the next one. We have a minus 2 before we square, and we add 5. So it's going to be 0 at x equals 2, and it's going to be going up 5. So let's see. I see a symmetry here, starts at 5, and then 6, 9, etc., and 6, 9, etc. So it's going to be the lowest at 2. Makes sense. X equals 2 right here. and it's going to be 5, up 5. So up 5. And one last one. Let's try -1, -2. Let's look for symmetry. I see the -2 and then -1, 2, 7, etc. Same thing here. That happens at 1. Notice that this is 0 when x equals 1. And we're going down 2. So I'd like to, again, pause the video and take your time to generalize what's happening to these functions. And what we're going to do next is we're going to import the graph and see if we saw on the table, if what we see on the table we also see in the graph. Okay, so here's the graph that we have. Let's find that blue. This is our base function. And now our g of x is x plus 3. So it's going to be 0 when x is -3 and down 1. Well, in fact, the only function that goes down is this one. So it makes sense that that's the x plus 3 squared minus 1. Let's look at the red one. So it's going to be 0 at 2, and it's going to go up 5. So 0, lowest at 2, and up 5. So that's the one it's going to have to be. Lowest at 2 and up 5. And then the last one is going to be lowest at 1 and down. Oh my goodness, I graphed +2, not -2. Oops. Okay. So that's a problem. So it would actually be down 2. It would be here if I had graphed it right. Okay. So I'll say, oops. This is the +2, and that one was what we really needed, was the -2. But you get the idea. Now, what would happen, again, I'd like you to describe this, but what would happen if you first, for v of x, if you first added 4 to the x, and then you added 2? So this would be 0 at a certain value of x, and then you're adding 2 to the whole function. And so I would like you to finish that up, draw the table of values, draw the graph, and then write some conclusions. So let's try to put this all together with a general function. Now, we used x squared for the base function before, but it really doesn't have to be. It can be any function. For example, this strange thing, we don't know what the actual function rule is for it. We're just going to call it f of x. So this thing is f of x. Whatever it does, it might cube it or square it or put it to the 4th power and maybe add a couple of things. I'm not sure. But that's our basic function. So let's take a look at these 4 different functions here and what we may have done with them to shift them to where they are. So let's look at b first. Let's look at this b. What do you notice happened to that function compared to the original? Right? Do you see that it was just shifted up? Right? Do you agree that it was shifted up 2, and that's all that happened? Up 2 to get b? So what we would have done is we would have taken b and whatever value we got, taken f of x and whatever value we got, we would have added 2 to it. Right, so it would be f of x, whatever that value was, we would have added 2 to it. Okay, let's try finding another one. How about c? How about c? What do you notice about c? Well, do you notice that for c, we shifted our bottom where it's 0, right? We shifted where it's 0. So the 0 is now at x equals 4. So instead of 0 being at x equals 0, 0 is now at x equals 4. So we messed with the stuff, the value of x in here. To make this 0 when x equals 4, right, don't we have to have an f of x minus 4? Because when x is 4, this value, this whole thing is 0. Okay, let's try A. This A. So what did we do? It looks like we went down to 4, to negative 4, and over to negative 3. So 0 at negative 3, x equals negative 3, and down 4. So we shifted the 0 so that our 0 is now at negative 3. So x plus 3 would be a situation where if we put in, if we substituted negative 3 plus 3 would give us 0, and then we went down 4. Right, so we messed with where the x value was when the at our 0 point, and then we shifted things down, or shifted the whole function down. And finally, let's look at D. Mark that in yellow. Oh, I'm sorry, whoops, that was A. A, and this is D. Okay. All right, so that was, and then D. And what happened with D was we shifted it down 3 and over 3, right? So now 0 at x equals positive 3 and down 3. So how do we make the 0 when x is positive 3? Right? X minus 3 will do. And then we need to subtract 3 to bring everything down 3. Okay. And finally, let's see if we can do the same, have the same process, but going backwards. So let's see. If f of x is still our original function, and for function e, we're going to add 2 to the whole function. So we're going to take whatever the value of this function was, of this red function was, and we're going to add 2. So if we had 0, 0, we're going to be at 2. If we were at 1 right here, we're going to be at 3. So notice that we're just going to shift, and this point is going to go up to 2. We're going to shift everything up. So this is going up 2 points. Okay, oh, no, that's already there. Okay, so how about for f? We have this minus 2. That means we've shifted our 0, right? For example. So instead of 0 being at when x equals 0, 0 is now when x equals 2. So we would have shifted this to 2. But we didn't just shift the 0, we actually shifted every single point as well. So the whole function is going to look like, pardon my drawing, like this. This is f. So it's going to be to the right 2. Okay, let's find another color. How about green? G. We shifted our 0. So now instead of being 0, 0, that value is going to be at negative 2, 0. Right? And then we're going to shift it down to all the values by 2. Okay, so negative 2, 0, and then down 2. Right, so actually we probably shouldn't write this value exactly. We should say left 2 and down 2. So let's see. Let's draw this function. And my drawing is getting worse and worse. Okay. That's G. And then H, finally. Let's look at H. h, we're going to be going, we're going to shift values. So now instead of 0, 0, b0 being, this being 0 at 0, it's going to be 0 at 2. So it's going to be right 2 and down 2. So it's going to be right 2 and down 2. So this is what that's going to look like. So that's going to be our h. So without even knowing the function, what the function actually does, what we can do is we can use our shifts, okay, our translations, to be able to redraw that function in a new location. We haven't changed the function, we just shifted it around a little bit. And that's why I actually called this the telekinesis. See, the telekinesis, it means moving from a distance, right? Shifting from a distance. And there's that poor kitty trying to do that to the spoon.